So let me set the context for the video. I was asked to build a visual RAG system for mathematics. So the challenge is the mathematical symbols or equations that we have, which is hard to extract from traditional PDF parsers or PDF loaders. So I tried a bunch of approaches here. So we compare and analyze all the possible solutions that I could think of, and then finally, using one approach, I've saved the data in quadrant. Quadrant is another vector store, and this is not the best approach that we have, but it gets the job done, and there's again scope of improvement that maybe we'll see in the demo. So let us start with the first approach that I could think of. This was my experience from the Amazon ML challenge, where we wanted to extract text from images. So the data that we have is the PDF of all the NCERT mathematics, let's say class 11th, and so yeah, this is the PDF. Using the first, so we compare the most traditional or most famous OCR modules, that is Paddle and Tesseract. So yeah, these are the results from Paddle and Tesseract. I have evaluated both of them on the whole corpus, but the thing is, sometimes it does identify the exact let's say symbol, like in the case of here Paddle, but it is like it fails at linear positions, and also there is no support of images, and let's say if there is matrix, then it fails to identify or extract the text from it. Maybe it directly have number in the extracted text, so that is not something that we want. The next thing that I tried is this PDF Plumber, which was another popular module. So this is the response that we are getting, with some issues with I think the encoding of the symbols that they have. But again, the same problems is with here. You do have the pages, but the image support is missing, and there's no structure in these numbers. So for a retrieval, this might retrieve things, but the unstructured data chunk would not make sense for LLM to respond nicely. So at last, I did use text to text, which was another famous model for mathematical equations, or let's say a support of latex or markdown, or latex supported markdown, which was helping us. So I think in the backend, what text to text uses some deep CNN or CNN, which so let us see in the demo. This was the output of one debug chunk that I maybe printed. So you see the result as in this, where it highlights all the relevant things or chunks in boxes or bounding boxes, and then it extracts using some VLM. I'm not sure about the backend, maybe I should have read that, but yeah. So then it gets converted into markdown. Maybe they're using some model that converts images or chunk of images to markdown support. These are the results, where you have all the figures that is available in that PDF in one place, and then the output MD, that is, if you see, is, I think that is what was required, or what was the challenge, where you have almost everything intact, all the information intact, and extracted from PDF to markdown with the support of latex. So so you have a very structured text support, or text or a knowledge base from PDF. So this is where this is helping. And if there is some matrix, which in this case there is not, let us switch to the next PDF, which is this. So you will see that there is support of matrix. Yeah, so it is able to figure out matrix, or yeah. So that is pretty much it. So finally, so yeah, these, as you can see, these are very structured question answers. So if we extract these and then parse into the model, there are chances, or better chances, that it will be able to figure out what is going on. There is, again, the scope is that for few text, the labels are not well structured or maybe well identified, but I think that is something that can be fixed or worked upon later. But the mathematical equations, as far as I could see or check from manually, the equations were nicely in a structured manner. So if you do a RAG on this, you'll be able to, the LLM will be able to answer things based on the contextual understanding of what the knowledge base is in the NCERT. So yeah, coming on to the demo of how the retrieval will work. So this is data.py, which is, let me maybe show this. So data.py downloads all the PDFs, converts them into images, and then save the full page markdowns from the, I think there is some issue, but yeah, so it does that. And then the quadrant.py is the file where I understand I could have maybe made a single file, but just for the demonstration purposes and for my testing also, I tried to separate all these files. So the quadrant.py kind of converts the chunks using the recursive character text splitter into embeddings using all mini LM. That is the very traditional embedding model that we use. And since I feel the retrieval will be based on text, so the embedding model is fine. We don't need to have any specific latex supported model, because we are not querying between if this is the symbol or this is the number that is in the chunk. We are querying the question, so which will be in the regular traditional text format or in NLP. Yeah, finally we have this retrieval. So if you want to check how the retrieval works, we can maybe have a look. So this is connected to Quadrant. So again, data, there is some issue with some library because I was trying to run the other modules. So I think there are some dependency issues. Yeah, in the meantime, the data has the data.py is the file which converts the files into the markdown. Quadrant is something that creates the chunks, convert it to embeddings, and then load it into the collection that is in the quadrant here. The data points that we have in the quadrant here in the name of the PDF chunks. And then the retriever is the retriever which helps us connect to Quadrant's client using the API key and the URL, and then you simply query and get the most ranked top 3 or top n, whatever you feel the value of n could be chunks, and then you get the results. Yeah, so now we can, so from the PDF we can check, let's say, types of relations, and then you'll be able to retrieve types of relation in a markdown format. This is, I think, some few slice of first chunk. So this is 1,000 character chunk, and let's do one more query to test from the second chunk. Let's say you want to understand a question, so you just simply ask a question, or maybe from theory you can ask find the principal value of sine inverse. Okay, this one. Maybe it is probably because of the support, but as you can see, but still you are able to figure out, find the principal value of the operator. Yeah, again, there is a scope of improvement, and if you're worrying about what these chunks are, these are in markdown format, but in case of retrieval, you just add a markdown support and you'll be able to see the support in the latex, so that is not an issue. So retriever is working pretty fine. You can query in other things. Also in the chunk, there is, if there is a figure, so that the chunk also references to the figure. So later in like after the retrieval of the chunk, we can have a tool called that if that has a figure, so that like push that figure also into the chat, or as a contextual understanding for the LLM. So that will also help us help the LLM for a better understanding of what the question is asking. Or yeah, so that is also the support of image that is helping LLM to generate better responses along with the text that has already been provided. So yeah, thank you.